Heidi-ho, Andrew here. Today I would like to teach you how to use synthetic division with functions that involve complex numbers. All right. Remember, I is defined as an imaginary number, and it's something that's made up. In other words, like taking the square root of -1. It's totally made up. All right. Remember, when you take the square root of something, you're asking yourself, what number multiplied by itself will give me the value inside of the square root, meaning -1? Well, no number will, because any number multiplied by itself will always give you something positive, not something negative here. Okay? So, how do we now do synthetic division involving this imaginary made-up stuff? Well, guess what? It's the same process as we've gone over in the prior videos. Same exact setup. There's no difference, and that's the beautiful part. Right? So if you've been following me here now for the past 50 videos, you already are very well aware and familiar with how to approach this. So watch. First thing is, remember, look at your numerator. That's known as the dividend. Locate the highest power of x, add 1 to it, and that will tell you how many columns your synthetic division table is going to have. So in this problem, we're going to have 4 columns. Take a look. Bam. So 1, 2, 3, 4 columns there inside of your synthetic division table. So now all you're going to do, start with the highest power of x, go x cubed, work your way all the way down now, x squared, x, you could write to the first if you wanted, all the way down to the constant. Now just start plugging in your coefficients that you see. So the coefficient of your x cubed term is going to be a 1, right? There's an invisible 1 in front, so write down a 1. Now if you don't see x squared, guess what the coefficient is going to be? It's going to be a 0. If you don't see an x term, guess what the coefficient is going to be? Another 0. And here's our constant, +1, so write that down. So now, after we have this fully filled out inside the table, you're done with your dividend. Focus on now your divisor. Take that divisor, x minus I, set it equal to 0. Add I to both sides, because what we're going to do is we're going to solve this for x. And the reason why I'm doing that is because whatever that result is, you're going to plug it into the outside part of your synthetic division table, so I goes out there. Once you have the entire first row filled out, you can now follow the simple series of steps for synthetic division. Drop the 1 straight down. Boom. Take that value at the bottom, multiply it by the value on the outside for a total of I. Put it in the next adjacent cell there, add it together. 0 plus I is going to be I. Then take your I here, add it to your I, multiply it by your I on the outside, and you're going to get I squared. Then, and you're plugging that into that next adjacent cell, add this together, you're going to get I squared. Then simply take the I squared, multiply it by the I, so then you're going to get I cubed. Add this column together, and you're now going to get 1 plus I cubed. Beauty. Now just remember what all these things represent, okay? This is going to represent your remainder, part of the remainder. This is going to be your constant term. This is going to be your x term. This is going to be your x squared term, right? I mean, you should be noticing that this is basically identical to what you've done before, okay? It's just now with an I in it, but who cares? That's the nice part about having a system. That's what we specialize in, building systems for you that you can utilize no matter how the problem changes, all right? Now, one thing you got to keep in mind is before you kind of conclude that these are indeed the values for your quotient, you must look back at your divisor, locate the x term, and identify that coefficient. In this case, it's a 1. What you would have to do, and what you want to think about, is you need to then divide each of these values by that coefficient. You do not divide the remainder. Now, obviously in this problem, in any problem, dividing by 1 doesn't do anything. So that's sometimes why it's skipped. But now if that's not a 1, if it's whatever it is, you're just going to plug it in down there, divide it, and whatever that math works out to be, those are your new coefficients, okay? In this case, though, it's not needed, but at least now you know what to do in case the problem changes. Now all you have to do is write out your quotient. So we got 1x squared. Where am I? Plus ix. Plus ix. Plus then, here's the constant term I squared. Plus then now, here's your remainder. So this is going to be 1 plus I cubed. Okay, all being now divided by whatever your divisor is, x minus I. Okay, from here now we want to simplify some stuff. All right, so I don't need a 1 in the front, so I'm just going to get rid of it. Boom. Don't erase the x, though. Then I realized that I have an I squared here, so I'm going to think to myself, well, what the heck is I squared? Well, if you know I is defined as radical negative 1, then I squared would be equal to radical negative 1 and the whole thing squared. Anytime you square a square root, you eliminate it. So in other words, I squared will equal just what's on the inside now, negative 1. So where your value of I squared is here, you're going to erase it and put in a negative 1. Cool. Now the only other term that you have to think about is this I cubed, right? So what do you think I cubed is now? Well, I cubed, and this could kind of be the easiest way to think about it, I cubed could be written as I squared multiplied by I, right? Now what is I squared? Well, we just defined what it is. It's negative 1. So I cubed is going to be equal to negative 1 multiplied then by I. And what's I defined to be? Well, it's simply radical negative 1. Now, you don't have to write the radical negative 1 out because, as you can already see, you can't really simplify it. You can't do any math there. So I'm just going to leave it as I. And then, cleaning that up a little bit, this just works out to be now negative I. So I cubed is equal to negative I. Try what I to the 4th is, all right? And then see if you can and then try I to the 5th and see if you can detect a pattern now between the I value, I squared, I cubed, I to the 4th, and blah, blah, blah. Okay? There is a pattern. So what you can now do, where you have I cubed, you can leave it I cubed, but sometimes they want you to clean that up a little bit. They might want you to write now, instead of I cubed, it's going to be negative I. Okay? And now you can pretty much leave this alone. All right, now it's probably pretty good. Maybe I'll clean this up and just make it a -1, maybe -1, and you're kind of done now. Okay, you don't really have to do too much more. I mean, maybe you got to simplify this, but who the heck knows? Leave it alone. It should be fine. All right. But guys, thanks so very much for tuning in. I really do appreciate it. I hope this video helped. And if it did, if you don't mind liking and subscribing, it helps us out tremendously. We appreciate all the support, all the great comments. And we look forward to producing more content for you. We have thousands of videos out there, not only in math, but chemistry and physics as well. So check us out if you're taking some other classes. I think you'll enjoy what you'll see. Take care.